We're talking today about real numbers, which we saw back on our first day of class includes just about anything you can think of. It includes, let's say, like double and triple digit numbers. It includes fractions. It includes decimals. It includes positives. It includes negatives. For our class, we don't really deal with decimals very much, so we won't be talking too much about that. When we do come across them, we'll have our calculators handy, so it'll be no big thing. We've already worked on fractions a little bit back in 1.3. You come across fractions in this section, and you need a little reminder of what we did. That was just a couple sections ago. So our real main focus today is going to be on like dealing with 2 and 3 digit numbers, pencil and paper, no calculator, and also the signs, positives and negatives. So how about to get warmed up, you try on your paper there, just with your pencil, no calculator, adding 753 plus 28, and then subtracting 753 minus 28. What are you getting when you add them together?
781.
Nice. And when you subtracted?
725.
All right. The way they were written here is not really the way you do it with your pencil and paper, is it? We actually want to stack the numbers up. Make sure they're lined up on the right side. In other words, the ones digits. And if there are tens digits, they should be lined up, and hundreds and so forth. And then where do you actually start the adding? Left side, right side, top, bottom? Right side, yeah. So we're going to go 3 plus 8 is 11. 1 down there, carry the other one. And then we'll add the 5 and the 2 make 7. 1 more is 8. Nothing to carry that time. 7 is the only hundreds digit, so it gets dropped straight down. So line them up on the right side and then start adding from the right, working your way to the left. Anything we could help out with on that addition with lots of digits? So subtraction, we also want the numbers lined up on the right, and we're going to start on the right. With adding, sometimes we have to carry. What's the extra thing you sometimes have to do with subtracting? Borrow? Yeah, because, for instance, we can't subtract 8 from 3, can we? So we're going to borrow 1 from that 5, and think of this as a 13 minus an 8, a 4 minus a 2, and there's nothing to subtract here, so we'll just bring down that 7. How about some questions for us on the subtraction? Let's talk a little bit about how signs work when we're adding. There's an addition rule number 1 on this page, and when we get flipped over to the second paper, addition rule number 2. So what it comes down to, these 2 rules, is whether we're adding numbers that have the same sign or not. So we're going to think first about adding numbers that have the same sign. Like the example you see here, the 2 and the 4 are both negative. Do you know what -2 plus -4 should make?
Positive number?
Oh, we got lots of guesses. All right, let's see. Well, let's think about where -2 is on the number line, and let's start there. If we're going to add a -4 to that, which direction should we go?
We go to the left.
To the left, 4 more spaces. And look where we ended up. So the answer there is actually -6. Did you want to say something else, James?
Isn't it only positive whenever you multiply them?
If you multiply 2 negatives, you get a positive, and divide. If you divide 2 negatives, you get a positive. Yeah. So thinking about the number line, it might kind of help make sense of why we got a -6. Because we know a -2 is on the left side, and if we're going to go -4 more, that's even farther to the left. So we're definitely going to end up way down there at -6. Picture's a great way to kind of get the idea of something, and then when you catch on, it'll help clarify down the road. What about 3 plus 1 on the number line? Where would you start to think that one through? Start at the 3, yeah, and then go 1 more to the right, and we're going to end up at 4. Now we knew probably 3 plus 1 is 4. Just an example of how even what we already know works along with these new negatives. Now, kind of studying on both of those examples, can you see where maybe the 6 came from? And maybe where the 4 came from? Just kind of ignoring the signs for a second. How do you get 6 out of a 2 and a 4?
You add them?
You add them, yeah. And how do you get 4 out of a 3 and a 1?
You add them?
The idea is because these have the same sign, you're going to be going the same direction the whole time. So we really add up all those values. And then we look at the sign to see whether we were on the negative side or the positive side. Can you use that information and try and read my mind a little bit to think what might go in these blanks up here? For what we've seen, when we're adding numbers that have the same sign, what do we actually do to their values? And how do we know what sign to put on the answer? Let's start with the values. Like the 6 there. What did we do to come up with that? We added, yep. It says absolute value because we're just disregarding the sign while we're doing that. Strip off all the negatives, add the numbers. And then how about that answer being negative versus this one being positive? Do you know how we could tell?
You kept the signs the same?
Kept the sign the same, yeah. A lot of times people think about positives and negatives dealing with money because that's something that's close to home, right? Makes a lot of sense to us. Kind of like if I owed somebody $2 and then I borrowed $4 more, I'd end up owing them $6. Yeah. It just adds to my debt when they're all negative. On the other hand, if I earned $3 and then I earned $1 more, I'd have a total of 4, and I'd be kind of broke when I was just $4. So we got the double, triple digits up at the top, the signs so far at the bottom. Let's flip the page and practice on that a little bit. For number 1, would you write down -4 plus -3? And for number 2, would you write down -6/12 plus -3/12? Let's just start with those two. In both of these examples, the numbers are all negative. So we're thinking about that rule we just mentioned where we're going to add the absolute values and keep the same sign. What did you get for number 1?
-7.
-7? Nice. Yeah, if it was a little trickier or we weren't sure, we get the 7 by adding the 4 and the 3 and then keeping the negative since they were all negative to start with. I throw a fraction in, but it's a hard fraction or an easy fraction? Easy fraction. What makes it a little easier? We've already got a common denominator. That's right. So we're going to keep that denominator. What else are we going to keep? The negative, because they were both negative. Yeah. And so when we actually do our adding, it really comes down to the 6 and the 3. So we're looking at a negative 9/12. That can reduce though, can't it?
-3/4.
Divide both by 3? Yep, to get negative 3/4. Nice. Anything you'd like to check on so far there? Alright, where it says number 3, how about we put down -17 plus -14. And for number 4, 389 plus 237. Does this make you look forward to chapter 2 when we get our calculators out?
As long as it's just us.
Oh, you got a couple weeks to track it down, huh?
I mean, well, I work at Walmart, so I can just buy one like I didn't have to.
When you get spend.
True. I also don't want to give them back the money they give me.
Exactly.
Anybody need another minute before we check them out? Like we're good there. All right, what'd you get for number 3?
-31.
-31.
Nice. The 17 and the 14 have the same sign, so they're going to get added together. 7 and 4 is 11. Carry the 1. 1, 2, 3. And then we keep the sign, so we make it a negative. How about number 4? What'd you get this time?
26.
Nice. They're both positive, so we definitely have a positive answer. Going to add those values together. 16, carry the 1. 11 plus 1 is 12, carry the 1. 3 plus 2 is 5. 1 more makes 6. Great. Anything you'd like to check on so far? So we're going to complicate things just a little bit because we're throwing in the second rule, which has to do with problems where the signs are not the same. So now more like -6 plus 4 or 5 plus -2. What would you say? How would you call it if the signs aren't the same? We could say the signs are different. Yeah. Is there another word that starts with an O? Was anybody thinking of anything else?
Opposite.
Different or opposite? You got it. So let's check out how it works when the signs are different or opposite. Do you know, for instance, what -6 plus 4 should make? -2. That's right. Let's think about what that would look like on the number line. -6 is first, so let's start there. Way down on the left side. And then we're going to add 4 to that. We should move where? To the right, 4 spaces. And that's what takes us to the -2. 5 plus -2, what should that add up to?
3.
3. And on the number line, if we started at 5, that'd be way down here on the right. And then we'd move which way and how far? To the left 2. We can see that we would land on the 3. So our first rule doesn't really apply anymore. When the signs are opposite, we're going to go left part of the time and right part of the time. Doesn't work like it was last time. In other words, the 2 doesn't come from adding the 6 and the 4 anymore, does it? Where does it come from? Can you tell? Like what's going on with the 6 and the 4 that makes a 2 here? And what's going on with the 5 and the 2 that makes a 3 there?
Subtract.
They're subtracted this time. That's right. Because they're going different directions, we really want the difference. And that comes from subtracting. So we can kind of see where the absolute value part comes from. And what about the sign part? Why did this one turn out negative, but that one turned out positive?
The larger number is a negative.
Yeah. You're going farther to the left than I am to the right. I'll end up on the left side, right? Correct? I shouldn't put another right in there. If I'm going farther to the right than I am to the left, I'll end up on the right side. So take the sign of the larger number. Can you fill in these couple of blanks then, based on what we just said? To add numbers with different signs,
Subtract.
subtract, yeah. The smaller absolute value from the larger absolute value. And use the sign of the
Larger.
larger. Good deal. Notice in the subtracting it says the smaller from the larger. So you might want to get in the habit of always putting the larger one,
On top.
yep, and the smaller one below. I tend to do that also when I'm adding, just to make sure I don't have to remember 2 different rules. It doesn't matter when you add which one's on top, but it does matter when we subtract. So larger ones minus the smaller one. Anything we can answer for you on those so far? When the signs are different. All right, let's see. For number 6 down here, would you write down 5 plus -3? And for number 7, maybe 1/5 negative plus 4/5. Kind of said that backwards. Negative 1/5 plus 4/5. We do have numbers with different signs, opposite signs in both of these examples, so we got the right kind of problem. What'd you guys get for number 6?
2.
2, great. And how about number 7?
3/5.
Nice. Nice. So just kind of thinking about how the rule applies, we're going to take the smaller value 5 minus the smaller value 3. And we're going to take the sign of the larger. With number 7, we already know we're going to have fifths, since that's our common denominator. We again want the larger value minus the smaller value. And I'm going to take the sign of the larger. Anything we could answer for you there so far? Alrighty. For number 8, let's write down negative 95 plus 52. And then for number 9, we'll try 84 plus negative 36. If you folks on Teams have any questions, feel free to just write them right there in the chat. I'll be sure to get them answered for you. So how about answer number 8? What are you guys getting on that one?
Negative 33.
Negative 43? And what about number 9?
Negative
All sound good? We're going to take the larger number and subtract the smaller number because the signs are opposite, so a little subtraction there. Did you have to borrow on either one of those?
8. Yeah, number 9.
Number 9, yeah, 4 minus 6 doesn't work, so we got to borrow. Make that a 14 minus 6. And then we want to look at our larger number in each case and see if it was positive or negative. What would you like to ask us about those? All right, hopefully it's not seeming crazy complicated so far, but we are going to mix those together a little bit on the next side here. And that's where the fun begins, where it gets a little interesting sometimes. So remember, 2 different things to think about: how to handle it when the signs are the same versus how to handle it when the signs are different. Would you start with negative 25 plus negative 74 and negative 3 plus 6? See what we think. So what are you guys getting for number 10?
Negative 99.
99.
Nice. And how about number 11?
3.
They look a lot alike, right? But we handle them a little bit differently because in number 1, what's going on with the signs? They're the same for number 10? Yeah, that means the numbers, the values are going to get added. And we want to keep that same sign. On the other hand, with number 11, to start with, the signs are opposite. So the 6 and the 3 would actually get subtracted, even though it's an addition problem. And we'll keep the sign of the larger. You think we can help one so far? Sounds like a good start. Let me give you a couple more to try. Let's see. All All right, so I've got negative 172 plus 643. And then I've got 84 over 37 plus 36 over 37. Ready for number 12? What'd you get on that one part answer?
471.
471? Did you actually end up adding or subtracting the numbers? Yeah, because they have opposite sides. So 1 there, 4 there, 4 there. 471 sounds great. Anything we could help out with on number 12? How about number 13? What was your answer this time?
127.
Nice. We had a common denominator, so the 37 stays. They were both positive, so the answer is positive. And the 84 and the 36 get added together. Plus, it won't reduce. And remember, we do prefer a top-heavy improper fraction. We wouldn't bother with a mixed number, so this looks perfect. Anything we can help out with there? I did add a couple notes up here. If any of this is kind of throwing you off, because the signs were the same, we added on number 10. Because the signs were opposite, we subtracted on number 11. One thing we've not done yet today is a fraction that doesn't have a common denominator yet. So how about I'll just kind of bring it all together. Let's see what you can do with negative 2/3 plus 1/7. We've got signs to think about. We've got common denominator to think about. Quite a bit going on. You know, we can't really tell yet which fraction is bigger. So probably a good place to start, if you're not sure, common denominator. Then it'll be more clear which one's larger. What are you going to use for your common denominator anyway?
21.
21? Sounds great. So we'll need to multiply it by 7, the top and bottom of the first fraction, and multiply by 3, the top and bottom of the second fraction. What will negative 2/3 be equivalent to? Negative how many 21sts?
14.
Negative 14 over 21, great. And how about the 1/7? That'll be equivalent to
3.
3 over 21. Looks like our answer will be over 21. 14 is bigger than 3, so it looks like it's going to be negative. See, 14 and the 3, because the signs are opposite, needs to be minus. Yeah. Negative 11 21sts. Sounds great. Did you survive that one? That's kind of the worst of it for us so far. We're getting lots of different ideas together. So a good place to start is the common denominator. Get them all matched up, then you'll know for sure what that sign's going to be, and you can do your adding or subtracting. Anything you want to double check about that?